All right, so picking up where we left off, it is Coach Richter's birthday, and we're going to do a little rendition of Happy Birthday on the video. Ready? Yay! Happy birthday, Coach Richter. 4-0 today. All right. Determine if the statement is true or false. Show why the statement is true or correct the information if it's false. A logarithm base 2 of 8 raised to an expression is equal to 4 times that expression. Okay, let's make a math sentence out of this, shall we? A logarithm, so that's log, base 2 of 8 raised to an expression. What do you want to say to the expression? Let's call the expression blob. Are you okay with calling the expression blob? I mean, we could be mathy about it and say that it's f of x if you want, but I like blob, okay? Is that equal to, here's the question mark, is that equal to 4 times the blob? Is it equal to 4 times the blob? Well, let's see. I need to try and make the left side look like the right side. So what could I do with the expression that's the blob since it's an exponent? I could do what? I could bring it out front. So I have blob times log base 2 of 8. Now, log base 2 of 8 is the same as log base 2 of 2 to the what? Third, right? Because that's another name for 8. And that becomes blob times what? What is log base 2 of 2 to the third? 3, right? 2 to the third is 8. So that becomes 3 times the blob. So is this a true sentence? No. 3 times the blob is not equal to 4 times the blob. If you want it to be true, you would have to say 3 times the blob on the right-hand side. Okay, so there you go. A little manipulation there shows that it's not true. All right, questions on example 4? All right, let's move on to the next example, example 4. What? Or you could just evaluate it. What's log base 2 of 8? Yeah, let me write that again. Log base 2 of 8. Remember we say 2 to what power is 8? 3. But I wrote it like this. Log base 2 of 2 to the third, because remember the formula says log base b of b to the x is just x. That's important. So this would just be the 3. In other words, 2 to the third equals 2 to the third. Yeah. All right, applications involving logarithms. Applications. The loudness of a sound. The loudness of a sound, L of I. L is for loudness, I is for intensity, okay? Is given by the function where I is the sound's intensity in watts per square meter, and I sub O is 10 to the negative 12. This is basically the faintest sound. This is kind of called the bass, the basis. This is the faintest audible sound. Okay, it's I sub O. It's our basis for comparison. So we always compare other things to I sub O. Like the Vuvuzela stream that I just did, we would compare that to I sub O. And then we would measure how loud it is by plugging it into this formula. So here it is. The loudness as a function of the intensity I is equal to 10 times log base what? What's the implied base if it's not showing in its LOG? It's implied to be 10. You don't have to write it, but I like to write it. Of the intensity over I sub O, which is 10 to the negative 12. Okay? So it's just like f of x. X is I, and f is L, right? So we could plug in. All right, so it says the intensity of a sound of a normal conversation ranges from 10 to the negative 10th to 10 to the negative 6. Without a calculator, what is the range of the loudness measured in decibels? Okay, so loudness is always measured in decibels, which is a tenth of a bell. The bell is named after Alexander Graham Bell, right? The phone guy. So this is a tenth of a unit of a bell called a decibel. All right, so let's just go ahead and plug in. We'll do two things. We'll do L of 10 to the negative 10th. We're going to plug that in first, okay? So what does that give me? It gives me 10 times log. I'm going to go ahead and put base 10 of 10 to the negative 10th over 10 to the negative 12th, just like that. All I did is I plugged 10 to the negative 10th in for I. Everyone okay with that? All right, now we do what the Marine Corps do. Simplify, do or die. Or something like that. Maybe they say simplify. It's very similar. 10. Log base 10. Let's simplify inside the parentheses. When we're dividing and the bases are the same, what do we do with the exponent? We subtract. What's negative 10 minus negative 12? Ah, careful. Negative 10, good. Minus negative 12 is really, here's my workbench off to the side. That's negative 10 plus 12, which is 12 minus 10, which is 2. Yeah, it's 2. All right, now let's simplify this. What's log base 10 of 10 to the second? What's log base 10? Whoa. No, look. What's log base 10 of 10 to the second? What's, yeah, what's log base b of b to the x? It's just x. So what's log base 10 of 10 to the second? 2. It's 2. And now what's 10 times 2? 20. So that's 20 decibels. All right, now let's do it on the other one. I'm going to move my workbench over here. Now let's do the next one. L of 10 to the negative 6 power. That's going to equal 10 times log base 10. I like to see the 10 there. Of 10 to the negative 6 all over 10 to the negative 12th. And we do the same thing. Let's simplify on the inside. That's 10 times log base 10 of what's negative 6 minus negative 12? Positive 6. Good. Now, we'll use the property of again. What's log base 10 of 10 to the 6? 6. 10 times 6 is 60 decibels. Or is it decibels? Yeah, it's an E, not an A. My bad. Decibels. Alexander Graham Bell. All right. So there you go. So we'll say conversation ranges, we'll answer the question, ranges from 20 decibels, that's how you write it, lowercase d, uppercase b, to 60 decibels, lowercase d, uppercase b, after Alexander Graham Bell. Did y'all know that coming into today? Normal conversation is between 20 and 60. Do you think the voice that I'm using right now, my teaching voice, is in that range? Is this normal conversation tone? No, if someone was talking to you in a normal conversation like this, you would say, shut up, dude. You're too loud. Shh, quiet, quiet, normal conversation. Use your inside voice. But my teaching voice is always a little bit more commanding. It's greater than 60 decibels. Okay? All right. And the vuvuzela noise, boy, that's probably like jet engine. We're probably talking 100 decibels, aren't we? Yeah. There's actually machines that maybe they have them in the science department where you make a sound and it measures the intensity. And it'll tell you what the intensity of that sound is. There's actually devices that measure in decibels too. You don't even have to measure the intensity and convert it. You've seen that like in sports arenas, right? Where people are getting excited and sometimes they show where the needle's going and it's like, man, this crowd is getting excited. It's Coach Richter's birthday. Get excited. All right. That concludes the notes. Now it's time for some more practice. Let's do this together. This is in addition to your homework assignment. We'll go through this kind of quickly. Let's just call this, if we can, rapid fire. I want y'all to get good at evaluating logs. All right. Express each of the following as a single logarithm and simplify if possible. It says to state the property that was used. I'm just going to state it out loud. I'm not going to write it. All right. What's log base 9 of 1? 0. Why? Because 9 to the 0 power is 1, right? If you want to write that, because 9 to the 0 power is 1. That's just the definition. All right, number 2. What's log base 5 of 5 to the 3x? 3x, boom. That's also a definition. That's the important one. Log base b of b to the x is just x. And the x can be anything. It's just a blob. Log base b of b to the blob is just a blob. All right, number 2. What's log base 4 of 64 to the 5th? Well, here's how we do this problem. I'm going to try and write 64 as a power of 4. 64 is what power of 4? It's 4 to the what? third, 4 to the third. 16 times 4. Okay? So now that I wrote 64 as 4 to the third, I can actually combine these exponents. What do I do with the 3 and the 5 here? Do I add them or multiply them? Ooh, it's exponentiation, so it comes down one rung. When you raise the power to a power, Lauren, we do what? Multiply, so we get 15. Okay? And now I can use that property that says log base b of b to the blob is just the blob. So what's log base 4 of 4 to the 15? 15. There you go. A little bit of manipulation, numerical manipulation. Notice how I put it in parentheses, though, and I just replaced 64 with 4 cubed, and then I combine the exponents. Why would it not be 5? Because what's 5 times 3? Why would, well, I just brought the 5 along for the ride. There's the 5, and there's the 5. I just brought it along for the ride. And then what did I do? I wrote 64 equivalently as 4 cubed. I just replaced the 64 with what 64 is equal to. And why did I choose base 4? Because that's my base right here. I want these to be the same number. Does that make sense? Got it? I want those. Yeah, okay. Log base b of b to the blob is just the blob. So as long as these are the same, I'm golden, as Harry Styles would say. All right. Everyone good now on that? That's an important realization for y'all to have. Okay, number 4, log base 8 of 32. Oh, my Jiminy Crickets. Can we write 32 as a power of 8? No, we can't. We can't. So what can we do? 8 to what power is 32? I got an idea. Can we factor 32 as 8 times something? It's 8 times what? 4. And now I can use the product property from yesterday to say that that's log base 8 of 8 plus log base 8 of 4. Yeah? Okay. Now what's log base 8 of 8? That's 1. Now I can focus on log base 8 of 4. Can I write 4 as the power of 8? Not really. Not really. But look, I could write this as log base 8 of 2 squared, can't I? And then I can bring the 2 out front. And this becomes 1 plus 2 log base 8 of 2. Now, can I write 2 as the power of 8? Yes. The cube root of 8 is the same as the cube root of 8 is the same thing as 2. So that would be 8 to the 1/3 power, yes? So I can say this is 1 plus 2 log base 8 of 8 to the 1/3 power. And now I can figure that out. What's log base 8 of 8 to the blob? Blob. So I get 2 times the third, which is 1 plus 2/3, which is either 5/3 or 1.667. Oh, I rounded there. That's one of the few times I round. I don't want to scare y'all by putting 666. Hey, if 666 is the number of the beast, then what is 667? The neighbor of the beast. But why haven't I had this all year long? This is great. All right, is that the only way to do that problem? No, you could have, if you were going to do it that way, you could have done this right here. You could have just said, oh, that's log base 8 of 2 to the 5th. Log base 8 of 2 to the 5th. 32 is 2 to the 5th. You could bring the 5 out front right away and say that's log base 8 of 2. And now you could do that little trick and say, what is this? This is log base 8 of 8 to the 1/3 power. And then you could just say that's 5 times the third, which is 5/3. And you can get the answer a little faster. That's a little bit faster, but what's 8 to the 1/3 power? 2, because it's the cube root of 8. So my goal there is to try and write 2 as the power of 8. And it is. It's 8 to the 1/3 power. We have to start thinking along these lines, right? I'm making you aware of the thought processes, these, so that you can have them for yourself. Is there another way to do it that's easier? I think y'all are good until I say 2 is the same as 8 to the 1/3. I think that's where we kind of get people, because we have a small number and we're writing it as a power of a big number, and we're not used to doing that. If y'all don't like that, let's explore another way. I'm okay with exploring another way. Can we use the change of base formula? Let's try it. The natural log of 32 over the natural log of 8. Will that work? That should work. Now that's the same as the natural log of 8 times 4 all over the natural log of 8, which if I split that up, now that's the natural log of 8 plus the natural log of 4 all over the natural log of 8. I don't know if this is going to be any easier. Now I can split it up, the natural log of 8 over the natural log of 8 plus the natural log of 4 over the natural log of 8. I don't know if this is going to be easier or not. And then we get 1 plus, and then I'm stuck over here. Oh, I know what I could do. Watch this. Watch this. Here's what I could do. Here, this will be easier. Watch. This is how we do it if we use the change of base formula. Don't write it as 8 times 4. This is the fast way to do it. Watch this. Put it in terms of natural log. Isn't 32 a power of 2? Yes, it's 2 to the 5th power. And isn't 8 a power of 2? Yes, it's 2 to the 3rd power. Now watch. I can bring the 5 out front, and this becomes 5 natural log of 2. And I can bring the 3 out front and call it 3 natural log of 2. And now what happens to the natural log of 2's? They divide out, and I end up with what? 5/3. So that's a way to do it without having to build the 2 up. Which way is correct? All of them. Why do students hate logs? Because there's so many different ways you can do the problem, and it forces them to do what? Think, which is the whole purpose of the class. Does anyone want to see it a different way or have insight into a different way? You think you're fine? Okay. All right. 3 is enough. All right. Number 5, log base 4 of 8 plus log base 4 of 2. Okay. Now I have 2 logs. Whenever you have 2 logs, it's going to be worth condensing it down to a single log. So I'm going to pull 1 log out, and since both terms are positive, what do I do when both terms are positive? Do I multiply them or divide them? I multiply them. So that's 8 times 2, and I get log base 4 of 16. And now this one's easy because I have a small base and a big number. That's easier than the other way around. What's 4 to what power is 16? 2. There's your answer. Okay. Or you can do this intermediate step if you want, and you could say that this is the same as log base 4, log base 4 of 4 squared, and then you could say it's 2. However you want. All right, how about this one? Log base 4 of 2 minus log base 4. Okay, so we got log minus log, so we're going to condense it again. We pull 1 log base 4 out. If you ever have a minus term, you're going to have a denominator, so build the shelf. The positive term argument goes in the top. The negative term argument goes in the bottom. So we get 2 over 32. Now we can simplify inside. That's log base 4 of 1/16. Now, you might know what the answer is right away. 4 to what power is 1 over 16? Negative 2. Fantastic. If you don't see that it's negative 2 right away, here's what you do. You try to write 16 as a power of 4. So that's going to be log base 4 of, first thing I'm going to do is call that 1 over 4 squared. And then I bring this to the top, and whenever I bring something to the top, I change the sign of the exponent to negative. And now I know log base 4 of 4 to the negative 2 is negative 2. But some of y'all are already at the point because you've been thinking all along, 4 to what power is 1 over 16? It's negative because I got to flip it. And 4 squared is 16, so it's negative 2. You can think about it that way. All right, the next practice. Given that log base m of 3 is 0.8 and log base m of 18 is 2.4, what's log base m of 6? Well, I have to be able to write 6 in terms of 3 and 18. So how do I write 6 in terms of 3 and 18? 18 divided by 3. So I'm going to write 6 as 18 over 3. Now I can use the quotient property, and expand it out. That's log base m of 18 minus log base m of 3. And now I can substitute in. Log base m of 18 is about 2.4. Log base m of 3 is about 0.8. And when I subtract, I get 1.6. Presto magic. Go, go, gadget logs. Oh, yeah. Logs make me happy. All right, now look, this is like a super warm-up problem. Log base 6 of 2 times log base 10 of 9 times log base 2 of 10 times log base 3 of 6. I'm going to go ahead and write the implied base of 10 there. I like to see it, don't you? Even though we don't have to, it's okay to write it. Now we're going to do what we did in the warm-up. We're going to change everything to what base? What's the easiest base to change it to? ln, base e, base e. So ln of 2 over ln of 6 times ln of 9 over ln of 10 times ln of 10 over ln of 2 times ln of 6 over ln of 3. And things should divide out. The ln of 10s divide out. The ln of 6s divide out. The ln of 2s divides out. And we're left with natural log of 9 over the natural log of 3. Now, if you want to simplify that, that's log base 3 of 9. Log base 3 of 9. Now, can we evaluate that? 3 to what power is 9? 2. 2. So this entire expression up here, you mean to tell me that whole thing is just 2 in disguise? Nice costume, 2. Didn't even recognize you. You could rob a bank in that costume. And people would be like, who robbed the bank? I don't know. It wasn't 2. But it was. Shame on you, 2. Don't be robbing banks. That's criminal. Questions on that one? All right, last one. Last one. True or false? A logarithm base 3 of 9 raised to an expression is equal to twice the expression. I've seen this before. Let's write a mathematical sentence. A logarithm base 3, so that's log base 3, of 9 raised to an expression. What are we going to use for the expression? Blob. Blob instead of f of x. Okay? Is it equal to, I'm going to put a question mark on the equal sign, is it equal to twice the expression blob? You already know it is? Yeah. Bring the blob to the front, and you get blob times log base 3 of 9. And what is log base 3 of 9? It's 2, so that's blob times 2, which is 2 times blob, and the answer is yes, it works. Or, I'm sorry, true. True. Not Nauer Clio. Nauer Clio. Mate. We're done with the extra practice. We're done with the notes. Okay, so you have the rest of the period to work on your assignment. And this assignment, the homework is due tomorrow, which is Thursday at 9 a.m. Tomorrow in class we review. And then Friday we quiz. Friday we quiz. Okay? There's only one more section left in the whole year. One more section, 14.4. Huh? Yes, we have one more test. It'll be next Wednesday. Test next Wednesday. Test next Wednesday. 5:15.